Hello, my name is Chris Wade. I'm the CTO with Itential, and we are a network software automation company. So we have a variety of presentations and demos we're going to go through. But before I get into that, I'm just going to give you some guiding principles that we think about when we're building our software, so you have some context for why we do what we do. So if you think about networking and we think about the management of networking, a lot of R&D has gone into data plane and control plane stuff, and I'm sure you guys have seen a lot of presentations at Tech Field Day and Network Field Day on that. We think how we manage a network is just as important as the speeds and feeds. And as we talk about the networks you're adopting these days, they're getting more and more complex, right? So we used to think about connectivity services. Now we're talking about SD-WAN. We're talking about data center overlay. We're talking about cloud networking. So the complexity of managing these networks is increasing. And the source of truth of these networks is now moving. So we started off thinking about the CMDB was a source of truth, or our inventory was a source of truth. Now we're moving into software controllers and orchestrators. So it's highly distributed. So what is the source of truth for a particular network these days is changing. So what's the source of truth for my overlay in a data center versus my physical network versus a branch? And if we think about automation, we start thinking about combining these sources of truth across complex networks, and we start to think about what sort of data do I need to perform this automation. So we need high quality data to make these decisions. And this data is in varying degrees of quality. I think most people would agree their inventory data or their asset inventory data is quite lacking. So most people, when they think about automation, we're going to talk today about kind of a crawl, walk, run approach. So when we have high quality data, we can make high quality decisions. When we have low quality data, we might need to assist it with some humans. And then we talk about what sorts of tools we're going to use. So from an Itential standpoint, we're a software company. We're going to talk about how great our software is. But you guys have lots of software tools. You guys are already using scripts today. You guys are using DevOps tools. You've had network infrastructure. We don't believe you need to toss that all aside. So what we're going to talk about is using the right tool for the right job, and how do we have an all-of-the-above strategy. And then ultimately, we're going to talk a little bit about a future state where we talk about infrastructure as code. We think that's the destination point. I think a lot of people in the room have talked about infrastructure code in the past. So we're going to talk about how do we take the knowledge we have in networking and combine that with software practices and principles so we can kind of take the best of both and drive it towards our network automation strategy. So if we think about a network element, we can really break it down into 3 planes. So data plane, control plane, management plane. And there's been a tremendous amount of innovation on the data and control plane. So you guys have seen presentations about hardware acceleration, data plane acceleration, data plane programmability, virtualization, using Linux OS as your operating system for your device. You've seen within the control plane, even before NFV was around, we talked about SDN. It's about centralized control. It's about moving your network into software. It's about that being the source of truth. So now I don't have to worry about each individual piece. I can talk to the controller, and I can inflict my change on the network. So if we think about SDN and NFV, I think a lot of people have been quite disappointed with kind of the adoption curve, how fast we've rolled it out, whether the virtualization and white box has paid for itself with traditional networking devices. But the point of the story here is that NFV and SDN have really put pressure on the management plane. So most people would tell you that you can see a demo of an awesome white box data plane with virtualized infrastructure, with centralized control, but why aren't we adopting it? It's because we've been investing in the data and control plane, and we haven't really been paying attention to the management plane. So if we looked at a general R&D split, I mean, the amount of R&D that's being spent on speeds and feeds and SDN controllers compared to what we're doing in the management plane, we think is underwhelming, and we think that's where we're changing. So if we think about phases to the network automation, we've really broke it down into 4 phases. So traditional network automation or legacy thinking was really around CLI and scripts. So when I made a change to the network, I was concerned about risk. I was concerned about mitigating risk. And when I broke something, I was concerned about what the blast radius of that issue was, right? I wasn't really concerned with how fast I would go, how responsive I was to application developers, how responsible I was to my end customer. It was all about mitigating risk and how I was going to break stuff in the network. And most services were very connectivity-centric, which I think is a simpler view of what we have today. So if we think about the current view, we're really infusing DevOps concepts into the network. So I think that's where we're at. We see people using all sorts of DevOps platforms. It's great. We're moving from scripts to standardized DevOps practices. And end customers expect self-service. So instead of me requesting a firewall rule in an email and a spreadsheet and expecting you 5 days later to tell me if I'm allowed to do that or not, I can now have some self-service capabilities to make that happen. And we're removing the network silo. So the network's typically pushed off to the side. The rest of IT, virtualization, cloud-centric applications are all automated with self-service capabilities. And what we're seeing now is that network silo is being brought back in, especially as we start to treat it like software. It can now be folded back into the rest of the IT infrastructure with the same level of automation expectation. So we really call that assisted manual. So it's still human-centric. I think everybody would say where we are today is still very human-centric, but it's augmented by a lot of machines. As we move to the next phase, we're going to talk about machine first. So from an automation standpoint, we really need to move from a human mindset to a machine-first mindset. So in this next phase, we're really talking, instead of self-service capabilities, now the application is going to be the dominant owner of requesting network services. So we need to be all about providing network APIs so these application owners can request overlay networks, network meshes, connectivity, policy changes on the fly. And it's going to be integrated with cloud networking. Saw some interesting stuff about the volume of VPCs in the world versus VLANs in the data center. I think some of that cloud networking is now going to kind of consume into the data center, so you're going to see more cloud networking concepts make its way into traditional networking. And then as the future comes, and that's the last section for today, we're going to talk about composable infrastructure, how does virtualization and software control take over, and ultimately how do we operate this as an infrastructure as code paradigm. So those are all fine as they come to phases and looking in the future. When we talk to customers, we really, they say, well, where am I at today? So this really resonates with customers in the market when we talk to folks in the sense that where we're at is we start down here and we have some CLI manual stuff. So nobody's going to debate that we start off historically from a very manual and scripted based scenario. And as people move along, they think, I have more changes to my network than ever. My network's becoming more complex, so I have to do something about this. I can't just have humans on CLIs and expect to be responsive to the business. So we start scripting everything, and that makes everything incrementally better. The next phase is we really start to adopt DevOps concepts. So instead of it just being Chris's script, now it's the organization's DevOps concept, or I can push and pull from other people that are solving similar challenges. And that really accelerates the capacity of automation. And we start doing some modeling things. We start thinking about creating generic models on top of CLIs, and those all help incrementally. But at the same time, somebody in the business or somebody in the CTO office is saying, hey, we have these new awesome networking concepts. We can't just put DevOps on top of my physical infrastructure. I need SD-WAN. I need data center overlay. I need software-centric networking. And I start to have these controllers and orchestrators being deployed in the network. And being a technology company, we think those are awesome. It's software representation of network. We get to do all sorts of awesome automation on top of it. The issue is, if you are the actual operations team, you're like, hey, I'm trying to automate my existing stuff. I'm retraining my workforce to be able to do scripts and DevOps platforms. And then I have these controllers and orchestrators come in, and the network team basically says, I have to operate two networks. I got my existing stuff, and I got all my new stuff. Like, how do I make all this work? So from an Itential standpoint, when we get into the product, you're going to see some things talk about how do we accelerate this blue line? How do we accelerate physical adoption? How do we accelerate the application of DevOps to your automation strategy? And how do you onboard these model-centric API-first software ecosystems? And ultimately, we need one operating model. We can't have this thing span off into two different directions. So from an Itential standpoint, when we start talking about the platform, how it works, you're going to see everything targeted at this integrated model. So there's certain aspects of the platform that are targeted towards your existing physical infrastructure. There's certain components targeted towards the more software-centric infrastructure. But at the end of the day, we need to have an integrated automation approach. So just a second on Itential. So we got founded in 2014. And how we got started was we thought that this revolution with controllers was the best thing to happen in the last 20 years. So back to the management data plane, control plane. There was all sorts of, NFV wasn't even around at the time. So we were at ONS doing OpenFlow and ODL stuff, thinking this was going to re-architect how we manage networks. So talking to the ONS folks and Guru, the question was, how can we participate in this? And at the end of the day, everybody wanted a killer app for SDN. So that's where we started with, was we were going to build apps for this SDN ecosystem. And what happened was that everybody wants to be the orchestrator and controller. Everybody wants to publish models and APIs, but there's nobody to consume those APIs. There has to be somebody on the other end of the line, right? You guys see presentations all day long of some controller who's producing some awesome model across some standard, across a very well-defined API, but the customer ends up having to do something with that. And the realization is that SDN and NFV concepts, although we push very hard for the generified open source model, is now being infused into every vendor product you see. So we used to have one data center controller, one WAN controller, and then we had a master orchestrator, and then Magic. Literally, there were slides that said Magic on it 5 years ago. So that hasn't happened. What happened is those have been infused. So what we have to do is now we have every vendor bringing a flavor of that, and it's great, right? Because the concepts of SDN and NFV are great. Virtualization, software control, we love these things. But the realization is now customers are not going to have 2, they're going to have 3, 8, 14. The firewall vendor gives you a controller. The load balancer vendor gives you a controller. The network mesh gives you a controller. Your public cloud vendors, your on-prem, your data center. So the idea is that we are the consumers of those APIs. We are the consumers of those models, and we allow you to manage the network using those modern ecosystems. And one question we get a lot is, who is our typical customer? So when we think about our customer base, thinking back 5 years ago, really the model was the people that were adopting those modern networking concepts were our first customers. So if you think of who was participating in that, it was the tier 1 service providers, it was the big banks and enterprises, and our customer base has kind of gone with the adoption of these modern networking concepts. So as people adopt SD-WAN, data center overlay, they need something to help manage it. I can't use my legacy NCCM tool that only knows how to talk to CLI to manage these controllers and orchestrators. People have to figure out how to consume that. So we help customers consume that and help drive the adoption of all this great technology. So before we get into specific demos, I just want to give you a high-level overview of the architecture because we're going to move around a little bit. So every platform you talk to has some adapter layer concept. So that's really how we can consume APIs. So there's 2 types of APIs. If you think back to that chart, you had the physical network kind of infrastructure, and you had your software-controlled infrastructure. So we have 2 ways to do things. Where we started off, back to how Itential got started, was really around the consumption of APIs and models from orchestrators and controllers. So if any of these network controllers produce an API, Swagger spec, Open API spec, Linux Foundation's done a great job with that. We can consume those and auto-generate adapters. We're going to talk about that later. And then if you have some local CLI that needs to be executed, maybe you're using a DevOps platform locally, we can turn those execution of scripts and DevOps concepts into APIs. I'll go ahead and draw the line on that. So within this, it's really kind of this integration layer. So the broker layer on top that Anand's going to speak about in a minute is really an intent-based interface on top of that. Because what happens is you typically don't have one of these things. You're typically going to have more than one. So if you have 5 data centers, you might have a DevOps engine running in each of them. So then you have to know, well, when I run that command, I gotta go over there to run it. So what the broker layer allows you to do is provide an intent-based interface to route to these different adapters. And the one thing I want to highlight is that, I'll probably highlight more than one thing, but from within the integration layer, it's really about providing an abstraction layer on top of customers, orchestrators, and controllers. So how do we build network automation applications? Historically, they were vertically integrated. And we typically called them tools, because that tool had to talk to a network element, had to have a database, had to collect stuff, and it gave you a clicky screen to do something on, right? You'd have a map, click on stuff, put some stuff in, hit the button, and it would apply to the network. So what happened is when you had 5 or 6 tools, you had 5 or 6 things talking to that network element, and then it was just kind of exploded from there. So the idea is that our platform allows customers to choose your choice of orchestrator and controller, just like you have a choice of network infrastructure. So we've taken on the challenge of not vertically integrating our application, but to build a platform on top of your choice of network infrastructure, which obviously is harder, but we think that's, if we look to our peer groups in other industries, this is how you build modern software stacks. We don't build tightly coupled, vertically integrated stacks anymore. So if we move on from the integration layer, and that's really that abstraction layer on top of the network, then we have a set of applications. And this is going to feel more like home for most network engineers. You're going to have things like configuration management. Everybody's used an NCCM tool at some point in the past. You have things like service management and policy management. We'll talk a little bit more about that in the application space. But these will feel familiar. These look and behave similar to how you've managed the network in the past. The tricky part behind the scenes, and why we want to talk about it a little bit more in depth in a minute, is these applications actually don't even know how they're going to do anything or what they're going to do it on. So they're just a behavior. They're an IDE. They're a client for doing this. The broker and adapter layer figures out where it goes, how it does its job. And ultimately, after you have these applications, which are quite intelligent, then you have an automation studio on top. We're going to go in depth a little bit later on that. And what that allows you to do is take all this network intelligence. So I have abstractions on top of abstractions. And now what happens is within the automation studio, I can coordinate these activities. Maybe you want to coordinate a backup with a compliance report, with a service lifecycle day 2, with a public cloud deployment.
So would it be fair to say that the whole top section is essentially your sort of declarative, part of the world, and then underneath where you're talking about, making your more tightly coupled or whatever down to somebody else's orchestrator, that's your imperative sort of, we're going to talk to brand X's controller, we're going to talk to blah, 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 we're going to talk to blah, 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 but the top is all kind of the same. You would configure your network the same regardless of vendor, or?
That's fair to say, and I think we'll get into, there might be a few nuances that I'd pick out, but
Sure.
Generally speaking, that's correct.
Okay. And just to confirm, it is a declarative state that we're defining here, like we're defining the end state of what we want the network to look like, right? And you guys are kind of translating that. If we say we want to go, have 25 devices spun up, it can determine we've already have 20 already deployed, and it'll just spin up another 5.
My only hesitation is there's a lot of IBNS, intent-based networking kind of dialogue filtered into the comment. So a lot of times those systems are ones we're talking to. So if something is declarative in nature, I'm going to respect the fact that it's going to do what it tells me it's going to do. So.
Okay, I gotcha.
So if I'm sitting on top of a system, and there's some systems that don't do that. So the idea is these apps have certain behavior, and the robustness of that behavior is going to be dependent upon your choice of orchestrator and controller. So the same system, you'll use it. If it routes to a system, I don't want to pick on vendors, but if it routes to a system that doesn't understand that, it's going to do its best to push, fire and forget, and be less intelligent about it. If I push it through a system that's more declarative, and it's going to keep pushing and make sure, and then maybe not async call me back and say I wasn't able to do it. What do you want me to do? I did to your point. I did 24 of the 25. How do you want to handle that? Then you can define how you want to handle that 24 out of 25 from the declarative state that did that.
Yeah, and you can control the dependency map downstream, so that's
you
what you're
can.
saying.
It's an abstraction on top of that coordination. So yes, in the general sense, and then when we get into a specific use case, then it depends on the subtending system. Our job primarily is to build this network automation capability off your choice. And the reason we do that is back to why we started the company. We think this is the biggest innovation time for network management. So, if you talked to me 5 years ago, so what's the ecosystem of like the most robust orchestrators, controllers, DevOps platforms, I would have a very different story than I have today. And I expect to have a very different story in 18 months from now. So we want to build on top of that ecosystem and ride that curve. Because at the end of the day, companies that were founded before that time, 2014, 2015, everybody wrote a device driver for everything, and they end up spending half their R&D just focusing on the new version of some flavor of a firewall or a network device. So we're seeing a lot of ecosystem development around how to do that, DevOps ecosystem, orchestrators and controllers, and we're the consumer of that to allow you to actually use it. Back to some of my earlier comments. Does it make sense? All right. So back to the automation studio. So this is, and we'll have pretty detailed demo on this, so maybe I won't talk about it too much, but this is how we coordinate those activities. Because I have different levels of abstraction. I can say, do this very specific thing on an SD-WAN platform. I can say, do this very general thing that for any adapter that registered to me. I could say, take these network intelligent capabilities. But when I automate something, when I turn up a brand new branch, when I deploy a new service, when I stand up a new application in the data center, I have different coordination of capabilities that I can extend. And we'll go into that in more detail. Time. And the last thing is, we'll talk about the integrations, we'll talk about the applications, and then the final is really about how do we take software principles and apply it to this. So in the networking world, we think we've done a great job of deciding when do we change the network. We do a great job of actually changing the network. We've done less of a good job about scaling. How do we have hundreds of people making changes to the same network element in a coordinated fashion? Software folks have figured this out for a while, right? How do we have lots of people with checking and balancing and testing and validation? How do we adopt those pipeline principles? And it's not about just moving all of your networking into some GitOps platform. It's about how do we take the best of both and how do we marry them together, and we'll be showing that at the end.